All right, so I'm following this booklet from yesterday that I provided you guys. I'm pretty sure I gave you the solutions as well. All right, let's get started. The chance of a fisherman catching a legal length fish is 4 in 5. If 3 fish are caught at random, what is the probability that exactly 1 is of legal length? So if 3 fish are caught at random, what is the probability that exactly 1 is of legal length? That means the first one, you've got a 4 out of 5 chance, and then the other two have to be of non-legal length, and then you would times that by 3. The reason why you're timesing it by 3 is because we chose this one to be the first one, and then second, and then third. What if the first one was not of legal length, but then the second one was, and then the third one wasn't, and so on? So you times it by 3. For those who do extension 1, I guess to you, that also means you're doing 3 choosing 1. That also works, as you could understand that. You've got 3 choosing one of them of that probability. The answer should be 4 times 3, which is 12. 12 over 125. So let's just say, Emily, would you say, yeah, like that's the style of question that is confusing you?
Yeah, I get it when you explain it, but like when I read it, the first step, I have no idea where to start.
Yeah, okay. Good. Well, okay, look, so if 3 fish are caught at random, so the way I would think of it is that's 3 different cases. So that's the first fish, the second fish, and the third fish. It says, what is probably that exactly 1 is of legal length? So if there's only 1 to be of legal length, that means if your first fish was of legal length, i.e. 4 over 5, then the other 2 must not be of legal length. So the way I think of these is very similar to, having kids. If you know that there's going to be 3 kids, your first kid, your second child, and your third child, then the first child, if you only want exactly 1 boy, so exactly 1 boy, you know that means it can be boy, girl, girl, or girl, boy, girl, or girl, girl, boy. You can't just say, oh, exactly 1 boy when you've got 3 kids. Oh, that's just a half, and then that's it. Or oh, that's a half by a half by a half, and that's it. But what about the other cases? So it's always important to think about, are there more than 1 case? And so I usually try to, whenever I do probability, I try to play the game. And when I say play the game, I mean like things like this, like maybe draw it out, try to understand what's happening, put myself in that position. I'll be the fisherman, for example, and then try to work out, oh yeah, but I could have, what if the first one it wasn't of legal length? Okay, that means the second one could have been, and so on and so on. Now, with the or, you could have done it as plussing, right? But if you didn't do it as plussing and you wanted to just straight away go, oh yeah, well, it's going to be the same probability, just change orders, so you can just times it by 3. But how about this, Em? Let's do the next one. I'll let you read the next one and tell me what you're thinking. 2-digit numbers are formed from the digits 2, 3, 4, and 6. So 2-digit numbers. What's the first thing you think I'm going to draw just by reading that 2-digit numbers are formed?
Just boxes, yeah.
Yeah, some boxes, some circles, something like that, with no repetition of digits allowed. A 2-digit number is then selected at random. What is probably that the number is prime? All right, first, let's get the prime clear. For it to be a prime, what's a prime number? Prime numbers are numbers that don't have any factors other than themselves and 1, and so on. Yes?
Yeah.
So
that would be...
Go ahead, yeah.
The prime numbers would be 2 and 3.
23. Well, you definitely know, let's get this clear. We definitely know it can't end in a 2, a 4, or a 6.
Yeah.
Right? So it has to be, so this number here has to be a 3. And then Then you've got three numbers left. You've got 63. 63 is not a prime. That's a composite. You've got 43 and you've got 23. So this could be a 2 or a 4. Pretty much you have 23 or 24. Those are your, not 24. 23 or 43. Those two would be the only two primes you've got. So now you know how many you have. You've got 2 out of. Now, how are you going to work out how many in total you could have? How many 2-digit numbers in total you could have formed? So now forget primes. Imagine I gave you just the first sentence now. 2-digit numbers are formed from here. No repetitions allowed. How many in total would you have said? How many numbers in total can you form? Do you know how to do that?
Since there's no repetition, you can't have like 22 and stuff like that.
Correct.
So it would just be like 12, wouldn't it?
Yeah, and how'd you calculate 12, just to make sure?
Well, I just did it by like the way that you do it with factorials, like around a table.
Yeah, that's exactly right. So pretty much how many digits can go into here? How many digits do I have that I can pick from that can go in the first box? That would be 4 digits. How many digits are left after you pick one in here?
There's 3 left.
4 times 3 is 12. And then, of course, 2 over 12 is 1 over 6. Sounds good? I know why this is a problem is because it's not, I would say even for me, when I was back in high school, this probability was the worst topic. Probability, perms, and comps, because there's no direct method that can work for every question. You've got to read, you've got to understand, you've got to apply. So I understand where you guys are coming from, but I hope by showing these different techniques, it's going to at least give you guys some tools for your exams. All right, 79. Who wants to try this? Let's try Tiana. It's going to be your turn. So I'm going to read, and then we're going to try to see what we can take out from this and how we would draw it up or start it off. 6 cards are numbered 1, 2, 3, 4, 5, and 6 and placed in a pile. So right now in my head, I'm literally imagining a pile of 6 cards. Right? Whatever. That's exactly what I'm doing in my head. A card is selected from the pile, and right now I'm selecting a card. Its number is noted and replaced in the pile. Right, so that's going to be replaced back. So there it is. It's number 3. Great. I'm placing it back. So I get it. There's going to be 6 again. See how I'm playing the game? A second card is then chosen and its number is also noted. What is the probability that both cards are a 3? Well, that's quite easy. Tiana, play the game.
Wouldn't you just do 1 and 6 times 1 and 6?
Very easy, right? The first card is going to be 1 out of 6. Second card, 1 out of 6. 1 out of 36. Excellent. Easy? Did it help that we played the game, or you just felt like, oh yeah, I kind of already understood what was happening?
Playing the game, I think, helps.
Yeah, I think so too. If you get it, you get it. If you don't, I think playing the game is what's required. All right, who's next? Let's try Aiden. Let's try this number 80. A bag contains 11 balls, of which 4 are blue and the rest are white. So straight away, you'll just write a little 7 there. 1 ball is selected at random and removed from the bag. Another ball is selected and removed from the bag as well. What is the probability that both balls are white? All right, Aiden, I think you're okay with this one. Tell me. So the first one needs to be a white. What's the probability of a white? 7 out of 11. And then the second one, so times 6 out of 10. All right, too easy. That should be 42 over 121, which I think... No, sorry, 42 over 110. Ugh. I did 11 times 11. All right. Imagine there was 121 there. See how quick it is to make a mistake? For me, anyways, multiple choice. You just got to be careful. All right, good. Number 81. And I think actually a good point that I just made there, you guys can see I don't really look at the answers. I just do the math first, right? There's different styles of questions. With other topics, you'll see I might not do any math. I might actually just look at the answer straight away and just be like, oh, it's this one. Because it takes you longer to actually do the math than it is to just maybe substitute the numbers in or whatever. But with probability, no, you can't look at this. It's not going to help you. All right, 81. Rad, let's try this.
Yep.
60 tickets are sold in a raffle. There are 2 prizes. Lincoln buys 5 tickets. Which expression gives the probability that Lincoln wins both prizes? Okay, he needs to win and then win. So, how many tickets does he have in total? Does Lincoln have?
He has 5 tickets.
5. That could have won in the first round out of how many tickets
60.
in total? 60. And then is it a plus or a times?
Times.
Times 4 out of
59.
easy stuff. Moving on. I think that's okay for everybody. Number 82, Aya. Let's just check if your mic's working and you can hear me. Well, yep.
Yeah.
In a school, the student population is 45% male, 55% female. 2 students are selected at random to represent the school. What is probably that both are female? That's very easy. The first one needs to be female, which is going to be 55%. And then?
And then would it be just 55 again?
Yeah, right. It's not like the one we did above. You're not losing any tickets. You're not losing any tickets. It's not like that. There's still a 55% chance. So 55 times 55. Make sense?
Yeah.
Just by me saying that, it made me second guess myself with number 82. Hold on. In a school, the student population is 45% male, 55% female. Yeah, no, I can't do it as 55 out of 100 because you don't know if there's 100. Done. That's right. Darcy and Leo. All right, who's next? Andy. Let's try 83. Darcy and Leo play poker. On each hand played, Darcy has a 60% chance of winning. If they play 2 hands, what is probably that Darcy wins both hands? I think you know it.
60.
Say that again. 6. Andy?
Yeah.
Yep. No. Can't hear you well.
Is it 60?
Is it just 60? Nah. On each hand played, Darcy has a 60% chance of winning. If they play 2 hands, what is probably that Darcy wins both hands? So isn't it that he needs to win the first one and the second one?
Yeah.
So shouldn't it be like that? 60% times 60%?
Yeah.
Yeah. So that should be 36%. Does that make sense?
Yeah.
84. Let's try that again, Andy. A different one. Paige owns 3 brown caps, 4 red caps. She selects one of the caps for herself at random and another cap at random for 2 friends. What is the probability of the 3 caps being red? All right, one more time. Paige owns 3 brown caps and 4 red caps. She selects one of the caps for herself at random and another cap at random for 2 friends. Another cap. Well, yeah. Caps. What is probably of the 3 caps being red? Okay. Yep. Okay. All right, Andy, what do you reckon? So, first one for herself.
4 out of 7.
4 out of 7 times
3 out of 7.
3 out of 6.
6.
right? Because you're losing one. She's already won it. Paige has won it, and then of course
2 out of 5.
2 out of 5. Careful. Paige, friend 1, friend 2. All right. Another, you can try number 85. Sam and Ashton play a tennis match against each other. The probability in any set that Sam wins is 3/5. So probability of Sam win equals 3/5. The first player to win 2 sets wins the match. What is the probability that the game ends at the second set? All right, might have to reread it. Sam and Ashton play a tennis match against each other. The probability in any set that Sam wins, any set Sam wins, is 3/5. The first player to win 2 sets wins the match. What is the probability that the game ends at the second set? What do you reckon? Can you tell me this? Can you tell me the game? Tell me what's happening in a tennis match. Yeah.
For him winning, it's 3/5.
Well, in any set, he'll only one set. It's 3/5. To win a match is 2 sets.
Yeah.
All right, let's forget a lot of the math for a second. So forget the math, the mathematics. Just tell me who can win. Let's start with that. Who can win? Answer that question seriously. It seems basic, but just answer that question. Who can win?
Both can win. Sam just has a higher chance.
Right. Hold on. So let's do that. Sam can win, or Ashton can win. But you need to take that into account. A lot of people would have missed the fact that Ashton can win. They would have just jumped straight to just Sam or whatever. So Sam can win or Ashton can win. Now, if we're trying to answer the question, which is what is the probability that the game ends at the second set? Well, that means Sam needed to win the first and second, or Ashton needed to win the first or second. Sorry, and second, not or. You need to win the first and the second. Yes?
Yeah.
Nada, do you agree with that?
Mm-hmm.
So it's very important, like I keep saying, those easy ones that we might be doing above, like, I don't know, this one here, what is probably that both are female, 55 times 55. If they're easy, they're not your big problems, but these ones here, we have to all learn to try to play the game. You've got to actually put yourself there, literally picture yourself, you're in the Australian Open, and you're like, all right, I'm this person, which I am, and then the other person is Ashton, and how can someone win? What is probably that the game ends at the second set? Well, it's either you can win or the other person can win, and that has to be taken into account in terms of the probability, because it's saying the game ends at the second set. Otherwise, if Sam wins the first and then Ashton wins the second, well, the game doesn't end at the second set. We move on to the third set. All right, Nada, ready?
Yeah.
We're going to win the first. Sam's going to win the first and win the second. Tell me the answer. Tell me the probability for winning the first.
3/5
And then winning the second?
times 3/5.
Correct. Or Ashton winning the first.
Is it 2/5?
Correct. And
2/5.
that's it. That would be the answer to this question, which should be C.
Okay.
All right.
Times in the middle, not plus.
You know why? And definitely means times.
Yeah, I go what you mean.
Or definitely means plus. Now, the way I think about it is am I in the same event? So is this the second set? Does that depend on the first event? Does the second event depend on the first event? Yes, it does. So therefore, that would be a times question, right? Whereas, can you have Sam and Ashton winning? No. So does this depend on this? No, this is completely separate. It's either you're going to win or you're going to win. So that's why it's a plus. Does that make sense?
Yeah, I don't know why I was thinking that.
Here's an example that nobody gets right usually. So listen to this. Ready? What's the probability? You have one child, right? One child. What's the probability of having a boy or girl? Tiana, what do you reckon? You have one child. What's the probability of having a boy or a girl?
'Cause
Yeah,
it's one.
it is one. You have 100% chance of having a boy or a girl. But what do you think most people say? Which is why you're laughing. They'll say half. Yeah, it's not. You have 100% chance of having a boy's half, or a girl, half. Half plus a half equals 1. What's the probability of having a boy and a girl if you have only one child?
It would be half.
No. Can you have a boy and a girl if you only have one child?
Oh, wait, never mind. No.
No. What is it going to be? Someone knows it, surely.
0.
0. You can't have a boy and a girl. That means you had 2 kids. You can't have 2 kids if you only had one child. But this is the one you guys are waiting for. Probability of having a boy. Oh yeah, that's a half. Probability of having a girl. Yes, that's also a half. But when you put and or, things happen. So here, like with this and, you got a half and a half, but this second child never even existed. So how is that even possible for this case? So that's 0. This, it's a or, so that's a plus sign, half plus a half. So there's 100% chance of having a boy or a girl. Can't have anything else. That's the logic. Sounds good, Tiana?
Yeah.
Confusing, I know, but it's important. Maybe you can just remember this case. So that'll remind you, oh yeah, wait, is this going to be a plus or a times? Now, the best thing is if they're the same event. So again, if I have 2 kids now, so now I'll rub this out. If I've got 2 kids, just watch, really understand one simple basic one. All the others, you just apply them the same way. All right, I've got 2 children now. 2 children. Probability of having a boy. So give me the situation of having a boy. If I've got 2 children, Tiana, what could happen?
Have 2 boys, or you could have.
Oh, I meant probability of having. Yeah, you're right. You're right. Sorry, I meant probability of having 1 boy. Go ahead.
It would be half.
No.
You could have a boy and then a girl, or you could have a girl and then a boy.
Yeah, you said or a boy, girl, or girl, boy. That means a half times a half, because the girl, the second child, depends on the first child, so it's going to be times, or different event, different situation altogether, so it's a plus, and then again a half times a half. You get that?
Yeah.
You can't just jump in and straight away say it's just a half or whatever. Play the game. I prefer that. I like that you just went and said now boy, girl, or girl, boy. When you do that, so just like I did here when I said who can win, Sam or Ashton, then usually you've got it out. But if you just go, oh, okay, just Sam wins, probably you just focus on Sam, and you forget about all about Ashton, well, it's not going to be right. But if you put yourself there, play the game, think about it, what could happen, usually you've a higher chance of getting these questions right. I'm moving on. I'm going to leave some for you guys to do because I think there's only 2 more left. Yeah. All right. I'm going to pause that recording for probability.